Hello, ladies and gentlemen. Today we are going to be doing scale 3.4a, which is equations of parallel lines. So I wanted to kind of just review with you what we kind of discussed in the last video. So there's really two major forms of equations of lines that are kind of used in certain situations. The first is the point slope form, which is the classic y minus y1 equals to m times x minus x1, where x1 and y1 are the point, and m is the slope. And then the slope-intercept form is your y equals to mx plus b, and our m is the slope, and b is the y-intercept. So my advice to you is, if you see an equation and you don't know what the letters or variables mean, that you really need to be making sure that you know what they stand for, look at the given information in your problem, and then you should be able to almost set them up on your own after that. Note, to compute slope, this is our rise over run. So all the time, students make mistakes and think that this equation is the equation of a line, but it is not. It is just the computation of slope. All right, so we're going to kind of see some problems today that contain equations of parallel lines. So, you know, we give you an equation that may or may not be in slope-intercept form. Sometimes it's in standard form and you have to convert to slope-intercept form. But there are a few things that you need to know on all the examples today. So your slope, if you are asked to find an equation of a line that is parallel, your slope is going to remain the same. So once when you computed the slope, you do not change what the slope is. Delta Math actually accepts both point slope and slope-intercept form. And it is my suggestion that if you are given a point, you know, like an XY coordinate, that you use point slope form, and that if you use, if you have a slope, if you have an intercept, a y-intercept, that you use slope-intercept. And it might actually be helpful for you when you work on the problems today, just to have like a box of all your variables. So I like to have m and x1, y1, you know, kind of laid out if you're kind of given a point. And then if you're given a y-intercept, I like to, you know, kind of lay out, you know, what my m is, and then what your b is as well. So this way, you can actually kind of effectively use the equations. All right, the first type of delta math exercise that I'm going to give you is actually just looking at graphing parallel lines and exploring their slopes. So the idea here is that you can kind of see what parallel lines look like, and how they kind of translate to the parallel lines have the same slope idea. So we will call this example 1. So the instructions read on this: to graph a line that is parallel to a given line and determine the slope of a given line. And I'm just going to get my graph here. And it says, click and drag to plot a parallel line. The line will change colors when a parallel or perpendicular line is drawn accurately. So what I like to do is kind of look at a rise over run. So I may look at the graph that is given to me, and I can see that this is a point and this is a point. And I'm going to do, my slope, which is rise over run. So my rise or lack of rise is down 3. And then my run is over 2. So I'm going to do that same type of thing with that yellow point. So I'm going to go down 3, and then I'm going to go over 2. And it changes color and gives me the slope. And actually, since I already kind of computed, I have the original slope and the parallel slope. So I'm just going to put -3 over 2. It would also accept -1.5 as well. All right, example 2. So on this example, you're kind of given a multiple choice question. We will call this example 2. And it says, which equation represents a line that is parallel to the line that's given? Now, the problem here is that this is in standard form and not slope-intercept form. So you need to solve for y. So if I do that, I'm just going to do that really quick. And I'm going to add 4x to both sides. And then I'm going to divide by 7. So then I get y is equal to 4/7 x minus 2. Hey, and what I can kind of see here is that there's one answer choice that has a slope of 4/7. So we need to have a slope of 4/7. And you're actually just going to go and choose that and submit your answer. All right, now on to example 3. So this example is our typical parallel line through a point type of question. And what we see here is that they actually do not give it to you in like y equals mx plus b type of form. So what I would do is I would actually just move the 2x over to the other side. So that way I could see the slope. So this would be -2x plus 9. And what I kind of notice here is that I am given a point, and I have also the slope now. So we should use point slope form. And I do this differently than on Delta Math. You are welcome to actually take a look, and I'll walk you through the solution on Delta Math of how they do it. But actually, Delta Math does accept point slope form. So what you're going to do is you're going to write down the point slope form. So that's the y minus y1 equals to m times x minus x1. Your slope is given once when we found the y equals mx plus b. So I actually like to kind of keep score. And I write down, what my slope is. So my slope is -2. My x1 is -1. And my y1 is equal to 6. And I'm going to put that in a box. And my equation would be y minus 6 equals to -2 times x minus x1. So that's a negative of a -1. And we can just clean that up a little bit. So I have -2 times x plus 1. And Delta Math would actually fully accept this answer. Now, if you wanted y equals mx plus b, what you could actually do is you could distribute the -2 with the x plus 1. So you could have y minus 6 equals to -2x minus 2. We could add 6 to both sides. and we would get negative 2x plus 4. And you would actually, that is actually the exact same equation of the line. So actually delta math will accept either one. I'm just going to actually put it in point slope form, and I'll show you what will happen. And then we got negative 2 times x plus 1. And it actually does accept. Now, the way that delta math does it is a little different. So they are still going to get for y equals mx plus b. They're still going to have you think through the slopes. But then what they're actually going to have you do is they're going to have you plug your x and y coordinate into y equals mx plus b, and you're going to have to solve for b. And it's a little bit less intuitive for some people. If you kind of like this way, I would really encourage you to kind of look through both the solutions on delta math and the way that I did it with point slope form, and see which one is working better for you. But what we care about is that you are able to get an equation of a line, of a parallel line through a point. And we will do one more. All right, last example here. This is example 4. And what we are going to do on this one is the exact same thing. So we have equation of a line that is passes through a point. So we want to do point slope form. So I'm going to kind of write that down on the side. And I'm going to solve for y, so I can get y equals mx plus b. So I'm going to move my x over to the other side. So that's going to be a negative x plus 6. And then I'm going to divide by negative 2. And this is kind of a 1x, negative 1x. And I divided by negative 2. So this is going to be y equals to 1/2 x minus 3. So my slope is 1/2. My x1 is going to be negative 6. And then my y1 is going to be negative 8. And if I'm doing this in point slope form, I'm going to write this as y minus negative 8 equals to 1/2 times x minus a negative 6. So that's going to be y plus 8 equals to 1/2 times x plus 6. And I'm just going to actually write it in that form. And we are good. So that is how we kind of do the parallel lines through a point. Next class, we're actually going to get some practice with perpendicular lines through a point as well.